Last page of examples is some similar types of ones. These are, if you notice, all the questions are saying what are the limits to infinity or negative infinity. But these are some unique situations. These are some types of problems that are not as straightforward as the ones we were talking about before. So the first thing I want to address is the exponential function. So exponential functions are when you have an x in the exponent rather than like an x squared or an x cubed. The x is upstairs. And the reason these are important is these are the only type of function that behave differently to the left and to the right. Because an exponential function, if you think about it, takes on a shape like this. And then, here's your x-axis, here's maybe your y-axis, something like that. But the right side of this function, as long as we're talking exponential growth, the right side of this function is heading towards infinity, while the left side of this function is heading towards 0. And then, of course, if you had exponential decay, that just goes the other way, right? So you would just have the opposite thing happening. You would have the left side of the graph heading towards infinity and the right side heading towards 0. But what that means is these are types of equations where we're going to have to pay attention to what type of exponential growth is it? Is it growth or is it decay? And we're going to have to pay attention to which direction we're going, left or right. So here's a perfect example of this. With this problem, we're heading toward positive infinity. So remember we said like the biggest thing drives the bus? Well, exponential functions are bigger than everything. Exponential functions will beat everything if we're making x bigger and bigger and bigger. So in this case, I would ignore the 2 and ignore the 5. Okay? And then I would say, well, what's going to get bigger faster, top or bottom? Well, since this has a base of 7, 7 to the x is going to be a lot faster than 3 to the x. Okay? And so I would say that this limit is going to be 0 because the bottom of this function is going to get bigger faster, and the 2 and the 5 aren't going to matter. But look at the next question. Next question is the same thing, except we're going to negative infinity. So when you think of 3 to the x and 7 to the x, those would be functions that look like this. As you go towards negative infinity, they're actually shrinking. These things are going to eventually go to almost 0. These things are going to get so tiny as you're walking out towards negative infinity that these are going to end up being the things that don't matter. And what's really going to be left is just the 2 over 5. Okay, and so for this one, I would say that this limit is 2 over 5. So this is the same function, but behaving differently left and right. I want to prove it to you. So that function was 2 plus 3 to the power of x over 5 plus 7 to the x. Okay, hard to see. Let me see if I can zoom a little bit. So the right side of the graph, you have an asymptote at 0. This thing is approaching the x-axis, and that's what we said, right? Asymptote at 0. But the left side of the graph is approaching something different. It's actually approaching 2/5. If I put in 2/5 here, that black line is now your asymptote, and you can see the purple is approaching that black line. Okay, if you zoom way in. So this function on the left side is approaching 2 over 5, and on the right side is approaching 0. And it all has to do with the fact that exponential functions behave differently to the left and to the right. Okay, the next two are a similar type of situation, and actually I think there's a typo. One of these should be negative infinity. Let's make this one down here a negative infinity, and let's talk about what's going to happen here. So we're going to do the same thing here where we say we don't care about the small stuff, right? I don't care about this stuff. I don't care about the minus 2. Now this we're going to look at, and we're going to say the square root of 25x squared. Well, it's an x squared, but it's living underneath the square root, right? And so if I were to take the square root of 25x squared, I could really just say that this is 5x, okay? And then I have 5x on top of 3x. The x's are evenly matched, right? They have the same degree. And so I would just say that this limit is 5/3. But what I want you to recognize is happening here is when you do 25x squared, that value has to be positive. This x squared is going to make everything positive. And that doesn't really matter here, because if we're going towards positive infinity, we're putting in all positive numbers anyway. But down here, we've got the exact same function. We're going to put negative numbers in for x. And what ends up happening is if you take this square root of something that's being forced to be positive, this 5x that comes out of it, I mean, we're going to kind of treat this the same way, but this 5x is being forced to be positive. Okay, we didn't really have to talk about that up here because we just assumed it was positive because we were putting positive numbers in for x. But here, if I'm putting negative numbers in, these are all still going to come out positive because they're being turned positive by this x squared. However, when I put those same negative numbers in down here, they're being allowed to be negative, right? If I'm putting in negative infinity, these numbers are going to turn negative. So I can still say that my x's cancel, but this limit is going to be a negative 5 over 3. So you only have to worry about that happening in this weird, like, square root of a square situation. And the reason for this, I feel like we kind of glaze over this in Algebra 1, but technically we're used to saying, oh, my pen's dying. We're used to saying the square root of x squared is just x. That's kind of a lie. The square root of x squared is not just x, it's actually the absolute value of x. Because if we put a negative number in here and square it, it's going to be turned positive. And then when we say we're going to take a square root, we really are only talking about the positive square root. So negative 6 squared is 36. If you type square root of 36 into your calculator, it's going to tell you that it's 6. Okay? So that's the situation here. Whenever you do this square root of a square kind of thing, just know that that's locked in as being positive all the time. Whereas the bottom, depending on whether you're going towards positive or negative infinity, could turn negative. It's kind of the same situation as our graph that does this thing, the absolute value of x over x. It's the same kind of thing, that one part of your fraction is being locked in as being positive and the other one is not. Again, let me prove it to you. So our function here is square root of 25x squared minus 3x plus 2 all over 3x minus 2. Reset my window. Okay, so over here to the right side, let's put in the line y equals 5/3. And you can see that sure enough, that blue line is an asymptote, right? The right side of this graph is approaching 5 over 3. The left side of this graph is approaching negative 5 over 3. Let me just throw a negative sign in front of there. There's your negative 5 over 3. And you can see that on the left side, we're approaching the negative version of that value. So these functions are really kind of funky looking. I would never expect you to know what this function looked like off the top of your head. And that's why it's really important that you can analyze it, using mathematical methods. Okay, let's talk about sine of 1 over x here for a second. So the sine function is an oscillating function. The 1 over x might change things up a little bit, but if it was just sine of x, we would say there is no limit because this thing just bounces forever. But I want you to take a look at what sine of 1 over x looks like. Okay. Sine of 1 over x does this weird thing in the middle. Well, okay, sorry, starting too many thoughts at the same time. My limit as I'm heading out towards the outsides is definitely 0, right? This thing is approaching 0. And I don't know that there's a super mathematical way to know that from here. I think you would just have to look at it on a graph and say, I can see that this limit is approaching 0. I think the question I actually meant to ask you here is, what does this function do as we approach 0? So same function, sine of 1 over x. Okay, so take a look at the middle of this graph here. As you're approaching 0, this thing just keeps bouncing. Okay, do you see I just highlighted? Those are all x-intercepts. Okay, I'm trying to get closer and closer and closer to 0. Do you see what's happening here? Is that it's just bouncing faster and faster and faster as I'm getting closer and closer to 0. Man, it doesn't even let me scroll anymore. So this does one of those oscillating things where even as we're approaching 0, we're not even going towards infinity, but this thing is bouncing so fast as you're approaching 0. This would be a limit that we just say does not exist. And the last one here for us to look at. So this would be one that normally I would say let's just cross off the things we don't care about. What I really want to address is this cosine, okay? Is this a thing that's driving the bus? Is this a thing that's controlling how fast this is growing? Well, I want you to think about what x squared is going to do. As x gets bigger and bigger and bigger, this is going to keep getting bigger and bigger and bigger. What's cosine going to do as x gets bigger? It's going to just bounce back and forth for eternity. So this is actually a function value that in terms of finding a limit, this is the thing I don't care about. Oh, sorry, dead pen again. This is the thing I don't care about because the cosine function is never going to be any bigger than 1, okay? And so I really just care about the 3x squared. Down here, I don't really care about the 1. So I have 3x squared over 5x cubed. Let's compare your x's, and x cubed is going to get bigger faster. So this one would have a limit of 0. I won't make you prove that one to me. Really, the big thing I wanted to talk about was that this cosine of x is not going to matter in the long run. Okay, that's about it. Those are your weird ones. Okay, so practice with those a little bit for tonight. Come on to class tomorrow and let me know if you have questions.